Okay, so we're going to look at 4.4, properties of logarithms. But first, what I want to do to remind you of what we did last week in section 4.3 when we were converting between exponential and logarithmic form and simplifying certain expressions. That's going to be helpful with what we're doing tonight. So let's just call example 1 and evaluate. And let's call this part A. We're just going to look at one problem real briefly. Let's say we have log base 4 of 16. So here we're in logarithmic form. And if you remember last week we talked about converting from logarithmic to exponential form and exponential form to logarithmic form. And so when we're in logarithmic form, you need to automatically think, okay, that means I need to convert to exponential. And when you do that, a lot of times your answer will pop right out. So set this equal to something. It doesn't matter what. Let's call it m. Alright, now this is log base 4 of 16 is equal to m. So when we convert to exponential, I said my base is 4, log base 4. And then when there's log in here, what's over here by itself on the other side of the equal sign is m. That's your exponent. And then what's left over is your answer. So for the m has to equal 2. And so we're going to be using this a lot more throughout this section and the next section. This will be a tiny part of a bigger problem. And so you'll have to know how to do this. And this is why we talked about some shortcuts last class for those of you that could hear what I was saying. So the first property we're going to look at is called the product property. And what the product property says, if you have log base b of x times y, or in other words, two things that are being multiplied together, then you can write these as break them apart and write them as two separate logs and add those two logs together. So you get log base b of the first term, x, plus log base b of the second term, y. So for example, let's try log base b of 8x. Excuse me, let's do log base 2 of 8x. Log base 2 of 8x. So you need to recognize, there's going to be several properties we're going to look at, and you need to be able to recognize which property we're using. And it'll come with a couple examples of working them. Product, you're multiplying two things together. That means you're going to separate them and add. So here we're multiplying 8 and x, so we'll break those into two different logs. So you have log base 2 of 8, your first one, plus log base 2 of x. And so that's our product property. But what you have to keep in mind is you need to determine if we've fully simplified this problem. And that's what you want to make sure to do. So here, this is as far as we can simplify. But over here, this goes back to example 1 that we just did over here. So if you can't see that this is 3 right off the bat without doing any side work, then do side work. The side work's very short. It's only 2 or 3 steps. So just look at this and set it equal to something, just like we did over here in example 1. We'll set it equal to y. My base is 2. My exponent's y. And that's equal to 8. So that means y has to equal 3. And so you replace this log base 2 of 8 with 3. So 3 plus log base 2 of x. And so let's just look at a quick example 2, and I'm going to just call it expand. Part A, natural log of 5xy. So remember, the natural log, that's the same thing as log base e. We just use ln as shorthand because it's one of those that we use a lot. So what you need to notice here is that we're multiplying how many things together here now? We're multiplying 3, 5x and y. So what the product property follows for however many things you're multiplying together, as long as it's in the same log parameter. So it's in the same parenthesis of that particular log. So your answer here would just be separating each of these in their own logarithm and then adding each term together. Natural log of 5 plus natural log of x and then plus the y. Hopefully that's pretty simple for you to understand. Well, we're going to come back to it here in a little bit. Next, we want to look at the quotient property. Yeah. So the quotient property says this, and it's very similar to the product. Quotient property says if you have log base b and you're dividing two things, so you can probably guess what's going to happen. We're going to separate them into two different logs, and instead of adding like we did on the product, we're going to subtract them here. So you get log base b of the top minus log base b of the bottom. So just as a quick example, we could have, if you had log base 3 of c divided by d. Following this quotient property, we can separate these into two logs with the same base, and we're going to subtract the two terms. So it's the log base 3 of the top minus the bottom one. Log base 3 of the bottom. And that's as far as we can simplify that one. If we were to look at a little bit more involved example, it would look something like this. Example 3. Again, I'm just going to say expand. Connect Math may have a little bit longer wording than that. And it may say something, write the logarithm as a difference or a product or a sum of multiple logarithms. Here's part A. And let's do log of x divided by 1,000. So you have to think back to last week. If there's no log, if there's no base written, what base does it imply we're working with? It implies we're working with base 10. So here you need to be able to recognize these properties right off the bat when you see them. Here I see that I'm dividing two things under the same log. So I can take these two things and write them as two separate logs and subtract those two terms. If I was multiplying in here, then that would tell me I'm using the product rule. And I can break them apart and add them. So just be able to recognize that and get faster at it. So here I can write this as log top minus, because it's the quotient, log of 1,000. So if you were to stop here, you wouldn't get the correct answer in Connect Math because you didn't this can be simplified a little bit further. Now, if you can't see what that answer is, how do you find it? You set it equal to something. So you say log of 1000 is equal to m. I'm just going to call it whatever letter. So my base is 10. My exponent is m. And that's equal to 1000. So m has to equal 3. And let's replace that with 3. So that's the answer you get. The last property is called the power property. And this one comes in handy in several ways. So its definition, or its formula, is log base b of x raised to the p power. So we have our normal base, whatever it is, and then our x, and that is raised to some power. So it's what happens here is the power property allows us to take that power, or the p here, and bring it to the front of that entire term. So now we're multiplying. So p times log base b of x. And a couple examples will help make that a little clearer. Let's say we had log base b of x squared. Let's not say b there. Let's say 5. Log base 5 of x squared. We follow the power property. That means we can take this power and move it to the front of this term, and now we're multiplying 2 times log base 5 of x. And it's as simple as that. So what we're going to get into now is using all of these properties in one single problem. Let's start off with kind of straightforward one. Example 1, 2, 3. So this is 4. I didn't do an example for the power property. Hopefully you kind of got the idea there. You're just taking whatever exponent you have, or power, and you're moving it to the front of that term. We'll get some more practice here. Expand, and we'll call this part A. Expand log base 2 of z cubed over x times y to the 5th. That's a cubed, and that's a 5. There we go. So if you want to give it a try, just go ahead and pause the video and give it a try and see what you get. I'm going to help you through this problem. So typically when we're expanding, there's a certain order that we'll usually go in, and that order is not set in stone. But just look at this problem and notice we have a quotient, we have a product, and then we have some powers here. So we need to be able to figure out what to use first and when to use it. Here we couldn't use the power or the product rule first. We'd want to use the quotient rule first. This product rule in the denominator, we're kind of stuck. We're kind of limited what we can do there. So by using the quotient rule first, we get everything on a single line, and that's much easier to work with. So let's do that first. So we have log base 2 of the top minus log base 2 of the bottom. And here you can put parentheses or not. So I'm okay either way. So now we have everything on a single line. And you can tell here we're going to have to use the power property here, but wait till the power property, it's usually the last one we do. Whereas the quotient rule is usually towards the beginning, and the product is in the middle. So here we're multiplying x and y to the fifth, so we can break these into two separate logs and add the terms together. So log base 2 of z cubed minus log base 2 of x, and then we're multiplying these two together, so we add log base 2 of y to the fifth. So now here is where a typical mistake is made. And we talked about this throughout the semester some. You have to look up here. This is minus this whole thing. So whatever we decide to change this into, or however we decide to form it, it still has to be minus this whole thing. So I didn't have my parentheses here. This negative has to be minus this whole thing. So that is a very common mistake. Up here it's minus this thing, and then we decided to rewrite this thing, and we rewrote it as this. But we still have to make sure that it's still minus the whole thing we changed. So the next step, I'm just going to distribute the negative. Alright, so I only distributed negative there. And now the only thing we're left with are these two powers here. So we can do that in one step. We're going to take this 3 and move it to the front of this term. We're going to take this 5 and move it to the front of that term. Three log base 2z minus log base 2x minus log base 2, minus 5 log base 2y. Yeah, be careful there. I made a little mistake, and that's easy to do. Okay, part B. I want you to pause the video and try it. I'm going to help out with the first step or two, and then after that, I'm going to want you to kind of take off with it. The only reason I'm doing that is because it's a little bit different in the beginning. So we have B and log, and kind of watch what I'm doing first before you write. That might be helpful. Log the cubed root of x plus y squared all over 10. So that whole thing, x plus y squared over 10, is under the cubed root. So you look at this problem and you try to decide what we need to do first. So you try to do the quotient rule, because that's what we talked about over here in part A. But we can't. We're restricted because of this cubed root. This cubed root is restricting us from getting inside of there and being able to manipulate it. So there's a way we can rewrite that. And you have to recall what we learned back in the first day of class, and it's prerequisite material, stuff that you should know coming in, but it's understandable if you need to refresh it. So let's just look at a couple examples. If you have the square root of x, what number is implied there if there's nothing? A 2 is the square root, so it means a 2. So this you can rewrite as x to the 1/2 power. If you have the cube root of x, well, that's x to the 1/3 power. If you have the fourth root of x, that's equal x to the 1/4 power, and so on. That just keeps going on forever. Whatever number you wanted, let's say 17, the 17th root of x, you could have x raised to the 1/17th power. So back over here, we have this cube root, and we can rewrite it as to the 1/3 power. So this is equal to log, and there's going to be too many parentheses here, so I'm going to use some brackets. You may need to just watch what I'm doing before you write it. And then all that's raised. So the brackets mean the same thing as parentheses do here. Just sometimes too many parentheses can be confusing and you don't know what starts where. So this is just saying this whole thing is raised to the 1/3 power. Now, we're still restricted here. We can't use the quotient rule yet because this whole thing is raised to the 3rd power. But how can we get that power out of there? By using the power property. So I can bring that 1/3 to the front. And I get this. And you could use parentheses instead of brackets if you want. Now this will allow you to start with the quotient rule. So I want you to pause it and try to take it from here and do your best to simplify it. Use me as a guide if you get stuck. Alright, so here we have the quotient rule property. So that says we can break this into 2 different logs and subtract those 2 logs. So 1/3 log of the top, which is x plus y squared, minus log of the bottom, which is log 10. And so this might have been a little confusing knowing what to put where, and this kind of comes back to the previous example we did where that negative where I drew in the parentheses because we used the product property over here and you had to distribute the negative into both of those terms. It's the same thing here with this 1/3. It's 1/3 times this log expression. And so if we rewrite this log expression, which is fine, but we still need to make sure it's still that 1/3 is multiplied by that entire log expression. So it's now, those parentheses need to go like that. Alright, and Connect Math may want you to multiply this 1/3 in here, but if you do that, do it at the very end. As far as what I would do or care about, I wouldn't care if you multiplied it in, but Connect Math looks for very specific answers sometimes. So if you're getting an answer wrong, it could be because of something like that. But let's look inside those parentheses and see what we can do. Alright, so here we have the power, so we can bring this 2 down. We can't do anything inside these parentheses because it's x plus y, so there's nothing we can do there. We're not multiplying, dividing, or anything. So we have 2 log x plus y minus log 10. And again, there's a lot of parentheses there, so sometimes you might see brackets. I'm just changing it up so you understand that it can go either way. And then we need to be able to simplify this a little further. This is good. So here, log 10. We need to be able to simplify that. If you can't see the answer is 1, then just do some side work. The side work doesn't take very long, so don't feel bad about taking an extra 30 seconds. Log of 10, and let's set it equal to, let's not set it equal to y because y is in the problem already. M. So we're in logarithmic form, convert to exponential to get our answer. There's no base written, so that means it's 10. Our exponent is m, and it's equal to what's left over, which is 10. So that tells me m has to equal 1, or this log 10 is 1. So that's what we replace this with, is 1. This is equal to 1/3, 2 times a log of x plus y minus log 10 minus 1. And again, I'm fine with this answer, but Connect Math may not be. So you may have to distribute this negative to make this 2/3 and make this minus 1/3. Okay, let's look at, so we looked at expanding one of these expressions. And so what we're going to do now is look at going the reverse direction. We're going to look at condensing them. So we're going to start out with this long expression with multiple logs in it, and we want to condense it down to one single log. And I forgot what example I'm on. See, this is where I need you guys. So let's see, 1, 2, 3. I think I'm on example 4. So I'm going to just give directions of saying condense, but what the directions may say are something along the lines of write the expression as a single logarithm and simplify it if possible, something like that. So let's call this part A. I may only do part A, but only do one example, but I'm going to call it part A. Let's say 3 log base 2 of z minus log base 2 of x, and then minus 5 log base 2 of y. Alright, so we're going backwards from what we just did, or what we were just working on. So let's think about what we did before. We typically did the quotient property first to separate everything out, and then in one example, we did the power first, and then the quotient. So the power is kind of interchangeable, just depending where we need to use it. So typically the quotient's first, and then we'd use the product rule property, and then at the end we did the power property again. So here we're starting at the end of what we were just doing. So here we would want to reverse the order. We want to do the power properties first and see if we can do some product properties, and then the last will be quotient properties. So keep that in mind. The very last thing we want to do is quotient property, because if we do it too early on, then things could start getting really messy. So here we notice that we have a 3 and a 5. And if I encourage you to try this yourself first. Go ahead and pause the video, but you may get stuck in the next step or two. But try it yourself, see where you get stuck, and just keep pausing and use me as a guide. So power property first. This is log base 2 of z. So this 3 comes up to the top now. Minus log base 2 of x. And this 5 now moves up here, of log base 2 of y. So it's important to keep in mind that all the 3 properties that I wrote on the board, the product, the quotient, and the power, they all can go back and forth between each other. Not between each other, I'm sorry. But so the power rule, you can go either way. The product rule, you can go either way. So if you have a single log with 2 things multiplied inside, you can break them apart in 2 logs and add them together. But if you have 2 logs with the same base and you're adding them, then you can go back to a single log and write them as they're multiplying to each other. So keep that in mind also. Alright, so next step here, we need to look at our problem and see what we have. So we have a minus sign here and a minus sign here. That tells us that we can use the quotient property, just going backwards. So we have two minus signs here. So we don't want to do the quotient rule just yet here. And this is if you worked it yourself where you may have gotten tripped up a little bit. If you do the quotient rule here, you'd wind up with a fraction over another fraction, and you could probably get there. But the trick I'm going to show you next will help you in a lot of these problems. And in fact, if you go back and look at the previous example, example 3, I believe, part A, if you look at the final answer, it was this. And what I'm doing is I'm actually working that example backwards just to show you, to hopefully help this make a little more sense with my next step. So go back to the previous example and look at what I did right here and what we did on the step before it. If you look, that's when I purposely did the negative sign wrong with the parentheses. So this is the step where I distributed the negative in. And then the step I did before that was where I had parentheses with a negative on the outside. So that's where we'd want to go from here. You need to recognize that when we have two minus signs like this, that these two terms are negative, we can factor out a negative out of them. And then you wind up with this. So log base 2 of z cubed minus, and then open that parenthesis, take a negative out of the first term and this term. So that becomes a positive. And if you follow along with example 3 part A, you'll see that these steps are following the same exact order, just in reverse. Now what this allows us to do is it allows us to use the product property right here. So let's do that. Minus then, so we have logs with the same base and we're adding them together. So that means we can write them as a single log multiplying these two together. So you get log base 2 of x times y to the 5th. And it's very important that you make sure that these two logs are the same when you apply these properties. Now you can notice that the quotient property is easily applied here because we have two logs with the same base and this is on the top divided by this. So this is much nicer looking than up here. So this is equal to log base 2. This one's on top. And then this one's on bottom. And that's all you would do there.